All right, so this is for section 3.3, where we're going to prove something about the derivative of sine and cosine. And in order to do so, we need to take a look at two limits that we want to consider. The first one is the limit as theta goes to 0 of sine theta over theta. And we're going to show that that limit is equal to 1. And then the second limit will be a little bit easier because we'll be able to work off this one, is the limit as theta goes to 0 of the cosine of theta minus 1 over theta, and we will show that that limit is equal to 0. Okay, so we're going to focus on this one first, and let's see how we're going to do that. So the proof is pretty straightforward, but it relies on some geometry. So let's take a look at some geometry. Here's a circle, quarter circle of radius 1. You'll have to believe me on that. And the other thing we need to know is that the area of a circular wedge, do you guys know it? That cuts out an angle theta is given by the area is 1/2 r squared theta. Okay, so just as a quick example, what is the area of this quarter circle? Well, we know it's pi r squared divided by 4, right? But would I have gotten it using this formula? Let's see, theta in this case is pi over 2. So if I put in a pi over 2 there, you see I get pi over 2 times 2 is 4 times r squared. So I do get pi r squared over 4. Good. So it does match up with some of our normal thoughts about the area. Very good. Now, what else do I need in this picture? I'm going to draw a point xy on the unit circle. And by doing that, right, I know that this length is 1. And then this is going to be angle, oh, I shouldn't have said x and y. I'm going to say this is theta. Theta. And so this point will be cosine of theta, sine of theta, right? So I'll just make that point A maybe. And then I'm going to continue this triangle out until I get to this. I'm going to draw a vertical from here. At 1, I'm going to call this point B. Okay, now I know the coordinates of point A. The coordinates of point A are cosine of theta, sine theta, right? And I know I don't know the coordinates of B yet. I'm going to try to figure that out in just a second. Okay, so the idea here is that you see 3 areas that we want to be concerned about. One area is the area of this wedge, the area of the wedge, right? And the area of the wedge is stuck between the area of the small triangle and the area of the big triangle. So area of wedge is stuck between the area of small triangle and the area of the big triangle. Good. So now we need to get some expressions for these 3 areas. Now, the area of the wedge, maybe I should write it here. Area of the wedge, we know it's 1/2 r squared. What is r in this case? R is 1, so that's 1/2 1 squared theta, or just theta divided by 2. Okay, now let's see if we can find our other areas. The area of the small triangle, the lengths of the 2 sides are cosine theta and sine theta. So the area of the small triangle then would be cosine theta times sine theta divided by 2. I'm using the 1/2 base times height, right? And then finally the area of the big triangle. To get the area of the big triangle, I know that this length has length 1, but I don't know what this length is. But you'll notice that if I take the tangent of theta, that's equal to b divided by 1, right? So we see that tangent theta equals b divided by 1, opposite over adjacent. And so therefore, b has length tangent theta. Right, so now I know what the area of the big triangle is. It's tangent of theta divided by 2. Good. And now we see that we can put this all together. Let's just work with, which one should we work with first? How about if we work with this one first? And then we're going to work with this one second. So if we work with this one first, we'll have the area of the wedge is less than the area of the big triangle. So the area of the wedge is theta divided by 2. So let me say this is, oh, I've already used A and B. I'll call this C, and I'll call this D. Okay, so this is C here, this inequality. Area of wedge is less than the area of the big triangle. Okay, so that means right away you can just drop the 2's, right? And then we'll have theta is less than sine of theta divided by cosine theta. Now, remember what I'm after. I'm after sine of theta over theta. So can I just divide both sides by theta, multiply both sides by cosine? Well, I don't have a problem as long as theta and sine and cosine are all positive numbers. And in this case, right, we're only really worried about theta small. And so we can assume then that theta is in this first quadrant where sine and cosine are going to be all positive. And so all of our values are going to be positive. So we can work this, we can go ahead and multiply and divide with random abandon. Okay, I don't know where that came from. Cosine of theta must be less than sine theta over theta. Okay. There's one big conclusion so far. Very good. So that came from C, right? Now, let's see what we can get from D. The area of the small triangle is less than the area of the wedge. So area of the small triangle, oops, am I not leaving? Oh, let me give myself some space. I write big. Part D. Cosine of theta times sine theta divided by 2 is less than the area of the wedge, which was theta divided by 2. 2's drop. And I remember when I'm trying to look for sine theta over theta. So how about if I divide by theta, divide by cosine? And so I end up with sine of theta over theta is less than 1 over cosine theta. Good. Good. Do you see how we're going to put these two together now? What is our conclusion from all of this work? The conclusion is that the sine of theta over theta for small theta is stuck between 1 over cosine theta and cosine theta. Very good. Now, why is this nice? You can see here I'm actually setting up the conclusion to the squeeze theorem. I'm squeezing sine of theta over theta between these two functions, right? And now if we take the limit as theta goes to 0, the bottom function goes to cosine of 0, which is 1. The top function goes to 1 over cosine of 0, which is 1. And so the conclusion of the squeeze theorem is the thing inside here has to go to 1 as well, right? And so thus, by the squeeze theorem, we have now proven our first limit. Very good. Okay, I'm going to pause here and get reset up for the second one. Okay, so let's see if we can figure out how to get this second limit. So let's take cosine theta minus 1 over theta. And the trick for this one is that we're going to multiply top and bottom by the conjugate, cosine theta plus 1 divided by cosine of theta plus 1. And if we do that, then the numerator becomes cosine squared theta minus 1 divided by theta times cosine theta plus 1, right? Good. And now cosine squared minus 1, does that sound familiar? we're going to use the Pythagorean identity. Pythagorean identity says that for any theta, sine squared of theta plus cosine squared of theta equals 1. Or you could bring the cosine squared over and take sine squared theta is equal to 1 minus cosine squared theta. Or you could, so we're going to take this to be the negative sine squared. So that'll be minus the sine squared theta divided by theta times cosine theta plus 1. Good. Now, you might notice that there's something looking familiar here. So I'm going to rewrite this algebraically, right, as minus the sine of theta divided by theta times the sine of theta divided by cosine of theta plus 1. And I can do that as long as I know that these two limits exist separately, right? So we know that this limit exists. That was something we just proved. And so the second limit is the thing that we're not sure about. In this limit, what happens as theta goes to 0? The numerator goes to 0, denominator goes to 1 plus 1, which is 2. And so the limit does exist for this expression as theta goes to 0, and it's equal to 0. Very good. So now we're ready. We take the limit as theta goes to 0 of cosine theta minus 1 over theta is going to be the same thing as the limit as theta goes to 0 of minus sine theta over theta times sine theta over cosine theta plus 1. And now we know the product of the limit is the limit of the products. Okay, we can just, okay. We know that, okay, I'm spending too much time on this. Times 0 equals 0. There it goes. Done. All right. So now our conclusion. This is our big conclusion of this video. The limit as theta goes to 0 of sine theta over theta is equal to 1, but the limit as theta goes to 0 of cosine theta minus 1 divided by theta is equal to 0. Good. And now in the next video, we're going to be using these conclusions to prove something about the derivative of sine and cosine.